Hey, how did you like that little trailer that I put together? In the last few months, I have been building various iterations of a dowel maker. The last one I did was an aluminum dowel maker that was based around a router table as its sort of engine. And then I had the idea, I just had a flash of an idea for a trim router version that would be more compact. And in my course of designing a version with the trim router, it solved a lot of the problems, a lot of the design and functionality problems that I was having with the router table version. And I'm going to show you the trim router version today. You've already seen it in the little trailer. I'm going to sell these on my website, which is www.bennetthandmade.com in the tools section. I'll leave a link below. This is home manufacturing, but it's pretty cool and it works. And I'm gonna show you what you get. I'm gonna put it together and we're gonna use it. We're gonna talk about a lot of different things. So if indeed you do buy one, then you can use this video as a resource. Okay, so if you order this, this is what you will get. It is a wooden base. This one's made out of poplar. I'll probably be making them out of maple, which is a little bit harder material. You get aluminum CNC cut rings. This is the front, so this is the iris ring where your square stock would go through. And in the back, this is your final dowel size. The first dowel sizes I made are all the sort of standard imperial sizes. And I didn't cut them exactly to, like say 5/8 isn't exactly 5/8. It's actually 1/64 over for all these dimensions. Why is it like that? Because when you're cutting and after you cut, you'll have to do a little bit of sanding, no matter how perfect the surface is. And you just want a little bit of sneak up room. So I created that 1/64 extra so you'd have a little bit of wiggle room to create your final fit or create your final surface. The beauty of this ring-based system is that these are interchangeable. You could swap this out with metric sizes. You could swap this out with one cut exactly to all the imperial sizes or odd imperial sizes. These can all be made on demand. That's something we have to talk about in sort of custom order, but they can be done. You could just collect a bunch of different rings to do a bunch of different things. Anyway, there's malleability there. There's some sort of gateway to different modules in the future. And that's what I really like about it. So again, wooden base, this clamps down, and then you get the acrylic base plate for the router. This one is drilled precisely for the Makita trim router. The Makita trim router is an incredible router. It's 1.25 horsepower. The thing is insane for its size. It's a very good router. It's the only one I have. So it's the only one I could use to create this and be absolutely sure that it functions. If I had all the other routers, I could drill all the other holes for it, but that's the only one I have so far. That may be a limitation for you, but maybe you have the Makita trim router and you want to go for it. In the future, as I assemble more routers, then I could do other fittings. So again, that's something to think about too. And we'll go over that in the next little part where I show all the stuff you need to use this. Yes, there is some extra stuff you need. I'm gonna assemble it now. So say you got this, you pulled out of a box, it's going to be wrapped in bubble wrap or something like that. Again, it's home manufacturing. And this is sort of what you would get. 99% sure that if I was going to send it anywhere, these things would just sort of be on the side. All the hardware, all the bolts and whatnot will come with it. So you want to find the little front that will have the iris ring on it. These are all marked, so to try and make it easier. And the first thing we're going to do is put, good God, I really don't want to drop. First thing we're going to do is mount the bottom acrylic base to it. The square side goes in the front here. These holes line up with the top. This is 1024 bolts and they're tapped into here. Gonna make sure it's nice and firm. There's 4 mounting points. You don't want to go nuts cranking on these, obviously, because it's just tapped into maple or poplar. But believe me, this is nice and firm. Next thing I'm going to do is put on the router base. And again, this is the Makita trim router. You know it, you love it. Very powerful. With the Makita trim router, it's not a complete square this way, so there's actually only one way it could go on, which is very reassuring. And it is like this. It is like this. The beauty of a CNC is it's so precise. It fits so well. I actually got the dimensions for this off the Lee Valley site. I didn't have to tweak it or anything, it just fit beautifully, so I was very happy about that. And you're just using the original black mounting bolts, which are M4 mounting bolts. I am pretty damn sure they are M4. All the Makita stuff is all metric. But when we get to the dowel maker, we're sort of in an imperial world. The dowel maker is all imperial. Everything is a 1/4-20 hex bolt, or this is these mounts are 1024 imperial. So it's all 1/4-20. So it's very easily accessible in North America. In Canada, you can just go to any Home Depot and get this stuff easily. In the US, obviously, you can too. If you're in Europe and this is strange for you, then I'm sorry, but I love 1/4-20. It's just very easily accessible, and I always have tons of it lying around. Okay, so we've got the pivot point, and it just really just goes on like this. This is captured, this is captured, this is captured. Now you can start to see the magic of the top, and it allows a pivot point here. So you can pivot, lock it down, and that creates the micro adjustment for sizing your dowels or sneaking up on that perfect size for your dowels during testing. And I am just going to add wing nuts to the top. These are very easy to just adjust along the way by hand. Okay, so you can loosen all these and you've got some pivot here. And again, you will see when this comes into play exactly. Before we get too far ahead of ourselves, let's look at all the extra stuff that it takes. This looks like just a crazy amount of stuff to drive this thing. It's nuts. But the thing is, I bet you have a lot of this stuff lying around. I bet you have a socket set, a drill, probably have a trim router if you're interested in this kind of thing. I'm sure you have clamps. You may have all this stuff, and it may just be an easy win to plug this little dowel maker into your system. And if you're making accurate dowels, whatever, you probably have all this stuff. So let's just go over it one time. Obviously, the trim router, and again, all this is based on the Makita. Right now, that's all I had. I had to make sure absolutely 100% it could function, so I used this. I just based everything around this. Mostly all the trim routers are kind of the same design, so I think it's an easy retrofit in the future to get into doing more of them, but right now, Makita. Next is the driving the dowels through the machine. So you need a drill. Cordless drill obviously is an asset here. It takes away one more cord. This is a very important part. A set, this is cheap, this is only like $30 on Amazon or something, but a set of these, I think they're 12-point sockets. Regular sockets won't grip around a square piece, but these 12-point ones just work really well. It fits really tightly on there, and you get a lot of sizes, and you can sort of find your size for your thing. When you get like the Lee Valley dowel maker, I think it comes with a very specific set of square sockets, but these star point ones work really well. You probably already have something like this. You probably already have a socket set, but yeah, they're not expensive. I recommend that because they work. And then clamps to clamp the unit down, and you'll see this while we're building. When you want to make fine adjustments, dial indicator. So this has a travel of 1 inch, and it's cut up into 1/1000th of an inch. This is very helpful. It's not totally necessary. You could just tap it into, you could just like kind of mess around with it and see where you get. But this is very helpful to give you some data on how far you're moving for your adjustments. You might already have all this stuff, so if you do, it's an easy win. Maybe you just have to get a component here and there. Something to think about when you're thinking about this system. So let's say you're getting ready to use this for the first time. So you've got your base, you've got your rings attached, they already come attached. You've got the router base mounted to the acrylic. So this is really everything you need to get it started. And then you're going to want to clamp this to a workbench or something. A lot of forces in play here, so you want to clamp it as firmly as you can. Let's do that. These F-style clamps. I originally designed it around a 1/2-inch router bit, but now I'm using a 3/8 inch just because it was the sharpest one that I had. It's good to use a sharp router bit. Probably everybody has one of these 1 inch long, 1/2 inch, sort of straight cut type router bits. So if you have a good one, just use that. Use anything you want, really, but the straight cut ones obviously work really well. That's what I recommend. Lock it down. I'm just going to go all the way down with the router. I've got my bit a good ways out, and then I'm going to start fooling around with this area. I'm going to set the router on spindle speed on 3 for this, which is a good mid speed. I've always found it cuts really well. I think it's around 17,000 RPM. I'm going to take off the ring for 1 second so you can see what's going on. You basically got this pattern of holes that matches up with this pattern of holes. There's a central pivot point, and then there's secondary mounting points that all lock it into place at its various sort of clock positions that hit all these in a center line running straight through. So all your different sizes that you would usually have in a bunch of different pieces, again, this is what I like about this. This is why I did it in the first place, was to eliminate all the waste from other systems. All the different sizes you need are all in this wheel. You're just going to spin the wheel to what you need. So for this one, I'm doing 5/8 dowel, which will be square stock 3/4. You're always ripping your stock 1/8 over to have some room to cut it down. I'm going to start with the central pivot point, leave it a little bit loose, and then add the secondary mounting point. You can see sort of where it lines up. And again, all this stuff is very precision cut on the CNC. So just the nature of the bolt, everything, it always reaches a good alignment by itself just by bolting it in there. Okay, so I flipped it around to the front side, and this is the final dowel size. So here I've selected 5/8. I've rotated the wheel along its central mounting point, and I've locked down the secondary mounting point. So now, theoretically, we have square stock going in from the back. It will emerge in this just over 1/64 over 5/8 size. So before we get into anything else, let's just go over some basic theory as to how this works. And again, there's a lot of this on YouTube of doing 2 different sizes holes and doing square stock in, the round stock comes out. You've probably seen this before if you're investigating making your own dowels in some way. What happens, the square stock goes in, it's cut by the router bit inside, and your newly rounded piece emerges here. The stability of the cut, this is important, the stability of the cut, it depends on a good connection. So when you've got it like just to the point where it's just fitting through here, and that comes in the tweaking process, the micro adjustment, when it's just fitting through, and also your square stock is really well sized. This is sized for 3/4. So if you have a really well done 3/4 stock and you've sort of test fitted it and you know that it's nice and firm. So you've got firmness here, you've got firmness here, you're rotating it, and there's a good, the rotational aspect of it is being well supported. You've got a good solid connection. That's what really helps the cut. Because if it's bouncing around, if this is too small, whatever, and if it's bouncing around, your drill isn't sending it well, then it's bouncing against the rotor bit, and you're going to have sort of like small gouges and stuff. You can see some of it here. The smoother this whole thing is, the more solid it is, the better it works, all right? So that's the basic theory. That's what you're trying to achieve with this. So I'm back to the front of the unit facing me. And the very first thing you're gonna wanna do to get set up for cut is we've got our iris size in position, we've got the final dowel size in position. Now, we can loosen the top, and we'll just move the router bit. You can see the edge of the router bit, and you're just going to want to just eyeball it to the edge. Once you start cutting your dowels, you'll have little end pieces like this, where you have a square bit and a round bit, and you know that this is a good size. You can actually kind of use that too, like feed it through, and you'll feel where the the router bit hits it. So you need a starting point, right? And you want your starting point to err on the side of cutting a little bit too much, cutting a little bit of a smaller dowel, and you can sneak up on the big size. Because if you go too big right away, there's a risk of it sort of jamming in the back, like it's trying to get forced through like a bigger size, get forced through that the hole, and it's too small, and it's jamming. It's not going to be fun to try and get it through. You want to go smaller, slightly smaller to begin with, and then sneak up on your final size. Sneak up very carefully, and then you'll get there. Once you're there, you can just run dowels all day. Now I'm going to add in the micro adjusting feature, and this element, this is what I really like. I couldn't figure out an easy way to add this onto the router table version. Some people on YouTube, commenters, geniuses, came up with the genius idea of using tapered router bits and such. That's given me new inspiration. But for now, on this one, this is the micro adjust aspect of it. You've sort of seen it in the trailer. Disclaimer. This is really awkward. I just made this. I have no good idea how to do this. That's the next step, is to come up with a better version of this. I think I can do it. I'd like to be able to give people something to mount their dial indicators on. These are all pretty standardized sizes, so I think if you get a dial indicator, they're all built like this. This is, the mounting point, it's like just like a quarter hole, so you can use the cord 20 mounting. I should be able to come up with something that I can just cut on the CNC, and so I'm definitely going to try it. But for this is just the tester version. I'm going to mount this right now. There are 2 tapped threads chapped right in the wood. Again, that's why I want to use maple. It'll hold the taps a little bit better. It's amazing how long I've had tapped wood threads that have just lasted forever. It's actually it's a viable system. I hate to say it, but it is. I'm just going to make sure that this is sort of hitting the center of the base plate. It just really just rides off the edge of it. So now when this pivots, we can get very fine indications of how far it's moving over. So if we want to open up the size of the dowel to make it a little bit bigger, if we want to close it down, etc. So the final piece of the puzzle is dust collection. If you don't run any dust collection, this is going to get filled up with chips pretty fast. Because this is an enclosed box, basically, the dust collection works spectacularly, but you have to have a vacuum hose going off it. And it's great. There's no shrapnel flying around like you get with a lot of other systems. It's very clean. This is one of the most excellent dust collection implementations I've ever made. 1 1/4 hole on this size. There's lots of 1 1/4 attachments out there. This is something I happen to have, which is 1 1/4 to the standard sort of shop vac size. I think it's 2.5, and that just goes like that. I'm going to hook up a shop vac, and you will see me using that when we actually start cutting a dowel. That's what we're going to do next. We're going to do a test cut. I'm going to see how quickly I can get to the ideal size using the system, hopefully with as little waste as possible. And then we'll just proceed to make some good-looking dowels and bring them into fruition. Okay, so now it is time to make the first test cut. I have my stock prepared. It is 3/4 by 3/4 square. Let's check if it's just a little bit over, but yeah, that should be good. You want a nice firm fit, so So maybe it's good to be a little bit over. Those sort of delicate edges will get compressed as they go in and form a nice stable connection. It's tapered to begin at the beginning. And I have the 12-point socket on the end. Very firm. I'm going to connect it to the drill. Got a vacuum attached. So the goal here is, this is about 13 inches. I'm going to try and get all my tests done within this to eliminate waste as much as possible. So let's get all our testing done on this one scrap piece. So I'll just run it through a little bit, check it with the calipers, and make adjustments. Okay, so I've got a little bit poking out that I can use as a test. You know what? It feels, oh my God, this is weird. It feels pretty firm right away. It doesn't normally happen this way, but, and it is reading 6245. 6250 is the ideal, but a little bit bigger so we have room for sanding. I'm gonna try opening it up a little bit. Man, that's pretty firm though. Okay, so let's do a little calculation here. I want my target size to be 0.630. 0.630 minus what we actually have is 0.625 equals 0.005. So I'm gonna half that because there's two sides. It's weird to think there's two sides of a circle, but yeah, there is in this situation. And yeah, so let's open it up by a 002. So I'm going to loosen these guys on the top. I had my dial indicator zeroed, and okay, we're already there. Hold on, you're just gonna, no, that's way too much. Okay, that's it exactly. So again, the theory is you want to get it tight enough just to fill the final exit hole, right? You want it just a little bit over your exact theoretical 5/8, your target dimension, so you have room for sanding, because you want to do a little bit of sanding to perfect the surface, and you want to have a little bit of wiggle for your final fits. Again, in my world, that's exactly what I want. In your application, maybe not, but you can always get dowel rings that are cut to the exact size. We can figure that out together. Okay, so with these new settings, I'm gonna do this and let's see if it's not too tight and if it works well. Okay, so I finished that. Let's pull it out. Surface finish is pretty nice. It's not perfect. There's a little bit of bounce, but that can very easily. There's no tear out. That's the main thing, man. Is there's no tear out, because it's very hard to sand out, tear out. But a slight texturing, very easy to sand out. So we're at 6300. That's exactly what I wanted. That gives that final wiggle for sanding. Okay, so let's see what we've actually taken off with sanding. Oh my God, yeah, now it's 6255. So we just took off like 005 with sanding. So really, effectively, that's bang on 5/8. The moral of the story is that within a span of, in our scrap piece, within a span of 13 inches, we got to the final dimension. I've had other moments where I had to go back and forth a couple times, but eventually I always got there. The main thing, router finish, very good. Sanding brings it just to perfection. Like it. Okay, so now I got another piece loaded up and say let's produce a whole bunch of dowels. Let's just run another one. Yeah, very good surface.